This video is for the area of a regular polygon. Notes, this is going to be lesson 8.4. So we're just going to start off finding the area if we're given the apothem. All right, the apothem is a segment that extends from the center of a regular polygon perpendicular to the side of a regular polygon. So this is an apothem. The apothem bisects the sides of a regular polygon. And then our formula for any regular polygon, okay, doesn't matter the number of sides, okay, as long as all the sides measure the same. Area is going to be equal to 1/2, so area is the big A, and then little a stands for the apothem length, and then big P, where big P represents the perimeter, and little a represents the apothem. So we're going to find the area of this pentagon. So the apothem is 9.91 yards. The perimeter, so 14.4 is one side. If it's a pentagon, it has 5 sides. So we would multiply one side times 5. So that's 72 yards. And then we can plug in to our formula here. Right here. So A equals 1/2 little a times the perimeter. And this one you just can type in your calculator. Nothing to solve. And my area is going to equal 356.76 yards squared. All right, now we're going to find the apothem. Find the length of the apothem of the hexagon below, then use it to find the area. So we're going to create a triangle using the apothem. So this is the apothem. I want to draw a line from one of the vertices straight down. Okay. We're going to find the measure of one of the interior angles of a hexagon. So remember our rule here. 180 times the number of sides minus 2. This is a hexagon, so it has 6 sides. So the total interior of this thing is going to be 720. There's 6 angles, so I'm going to divide by 6. And each of these angles in here is going to measure 120 degrees. Now, when I draw this radius in, I split this angle, this corner up here, in half. And so the part that's inside the triangle is going to measure 60 degrees. Remember, the apothem bisects the side. So if all the way across the side is 9, halfway across the side is 4.5. What we've done is we've created a right triangle here. And if we know an angle and we know a side, we can use SOHCAHTOA to find the missing side. We're looking for the apothem. So this side of the triangle that I drew in, that's the hypotenuse. If this is my angle, then X is adjacent and the 4.5 is opposite. So opposite and adjacent is tangent. So tangent, and my angle is 60 degrees, equals opposite 4.5. Oh, I did that backwards. I did. This is opposite. I'm sorry. That's opposite the 60-degree angle. This is the adjacent side. Opposite over adjacent. All right, to solve this, let's try menu 3-1. Tan of 60 degrees. Make sure that your calculator is in degrees when you do these. Okay. If we round this off, it's going to give us a pretty gross answer. It's easier to use the whole piece. So what I mean by the whole piece, if we would solve this by hand, okay, if I want to get x by itself, right, X is being divided by this, so I would want to multiply both sides by 4.5. So what I'd get is 4.5 times the tangent of 60 degrees, and that equals X. I get a more exact answer if I use that expression for the apothem over rounding off this decimal, and I'll show you what I mean in a second. I'll do it both ways. So now we have the apothem. The only other thing that we need is the perimeter. So the perimeter of this thing, it's a hexagon, right? So if each side is 9, it's got 6 sides, so my perimeter is going to be 54. All right. Area equals half of the apothem, 4.5 times 10 times 60 times the perimeter. Okay, so here's what I want to show you. If I do, say I round this apothem off to 7.79, okay? And then the perimeter is still 54. My answer is 210.33. So now let's use the expression instead for the apothem, the 4.5 times 10 times 60, and then times the 54. It changes your answer. I know it's slight, but when we have to round, there's a difference between 0.33 and 0.44. So we're going to be using probably the expression rather than the decimal for these. And this is feet. So feet squared. All right, finally, use the area of the triangle. Yeah, use the area of a triangle below to find the area of the octagon below. So we've got the apothem again. We're going to create a triangle using the apothem as the height and the side of the octagon as the base. Sorry, I'm looking at this and trying to decide what I want to do. Okay, if we make another one of these triangles, okay, make a right triangle in there. If it's 6 yards all the way across, halfway across, this side of the triangle is going to be 63. We're looking for the length of the apothem, and we need that angle measure. So that angle measure is going to be 180. This is an octagon, so it has 8 sides, so 8 minus 2, and then divided by 8. So one angle on the inside here measures 135 degrees. We cut it in half for that triangle, and so we get, it's hard to write in there, 67.5 degrees. So I know that's still kind of small. 67.5 degrees is the measure of that angle. Okay, so to find the length of the apothem, we've got, here's our angle. So this is the opposite side, this is the adjacent side. We're using that tangent ratio again. So tangent of 67.5 equals opposite over adjacent. And then again, we are going to rearrange this. We're just going to multiply both sides by 3. So we're going to have 3 times tangent of 67.5. And then we can find the area of the triangle. So what I'm going to do is I'm going to extend this triangle out like this. Okay? Area of a triangle is 1/2 base times height. So the base here is going to be 6, okay, all the way across. So see the new triangle that I drew? The base is one whole side. So 1/2, base is 6. And then the height of the triangle is this apothem, this 3 tangent of 67.5. So this is just another method you could use. You could do exactly what we did up here, and we'll actually probably do that and look at what answer we get and compare them. Okay. And so again, we get a decimal, so I don't want to mess with that decimal. What I can do is I can multiply these coefficients. I can do half times 6 times 3, and what I get is 9, and then that tangent 67.5 is still there. That's the area of the triangle. Then it says multiply the area of the triangle by the number of triangles that can be created within the octagon. So I can make one, I can make another triangle here, 2, 3, 4, 5, 6, and then 7 and 8. I can multiply this area by 8. And I get, so my area is going to be about 173.82, and we're dealing with yards, so yards squared. If I'd use the apothem, this is the apothem in the formula. Remember, the formula is half times the apothem, so 3 tan 67.5 times the perimeter, 6 times 8. One side measures 6 yards. We have 8 sides, so that's how I got that. So if we compare the areas that we got, they're exactly the same. This is just another method you use. If you want to just use the formula, that's fine. So that's it for this set of notes.